I hope the screen is visible to you. Yes, thank you, Shrish. Yeah, good evening, everyone. So, welcome to the live session for the week 10 of Advanced Concrete Technology. So, in the past week, we learned more about creep, shrinkage, and the different factors which affect these two time dependent deformations. So, without further ado, let's move into the questions. Yes. So, here is the first question for today. Choose the aggregate which could possibly be used for radiation shielding concrete. I'll post the same in the chat box. Yes. Okay, thank you, Shrish. Thank you, Hemant. Okay. Yeah. I'm getting different answers like between C and D. Yes, I'm waiting for others also to respond. Please feel free to respond in the chat box. Okay, I guess that's it. So let's move to the correct answer. Yeah, the correct answer is D. I guess except one, all have answered it correctly. Yeah, so why magnetite is because it is a heavyweight aggregate, and generally for radiation shielding concrete, we go for high density concrete, not the normal concreting. So for the design of high density concrete, it is preferable to use high heavyweight aggregate. So, among the given options, magnetite from the iron background is having a high density or the heavy weight. So, we go for the option D as the correct answer. Okay, we move to the next question now. Yeah, the next one is circumferential expansion of cylinders are to be controlled in the displacement controlled compression testing of cylinders. Whether this is a true statement or a false statement. Okay, so cylinders, it is a different way of testing for compression, and we can also check the displacement of the cylinder when it is being compressed. So the current statement says that the circumferential expansion of cylinders are to be controlled. It doesn't say about the direction in which the load is applied, or it doesn't say about the lateral direction. It says that the circumferential expansion has to be controlled. I guess this question doesn't need any more further explanation. Yes, moving into the correct answer. Yes. So the correct answer is A, which is true. I think all of you who have responded in the chat box have responded it correctly. Congrats and thank you for that. So when you test for a cylinder, especially in the case of an uniaxial compression testing, as you can imagine, the cylinder can bulge outward along the curved surface. So, by noting down how much the displacement occurs, we can get an idea about the material, and hence it is very mandatory that, or it is very useful to check the circumferential expansion of the cylinders during an uniaxial compression testing. Okay, so these two were fairly easy questions. Yes. So the next one is related to the time dependent deformations, that is creep and shrinkage. They are primarily caused due to aggregates, the CSH, ITZ, or water. Read the question carefully. The time dependent deformations of the concrete are primarily caused due to aggregates, CSH, ITZ, and water. I'll wait a few more seconds so that others who wants to respond can respond in the chat box. Yes. Thank you all for responding it very fast. Again, the time dependent deformations are caused due to aggregates CSH, ITZ, and water. Okay, so let's go to the correct slide, but yeah, so the correct answer is D, that is water. I understand why many of you have responded B because that is one in the paste phase, but that is not just the composition of the paste. The question it says that it is caused due to, so the deformations, let it be creep or shrinkage, they are caused due to the movement of water. It can't be caused due to CSH. Just CSH is present doesn't mean that the concrete can creep or shrink. It requires water. If the water moves within the structure, then creep can occur. If it moves out of the structure, that is, there is a volume reduction, shrinkage can occur. So, hence, the all the time deformations of creep and shrinkage are primarily caused due to water and not due to CSH. Okay, I hope that is clear. Let's move to the next one. Okay, again, the question is on this creep and shrinkage. The time dependent deformation strains are permanent and non recoverable. It's again a true or false question. So, the time dependent deformation strains are permanent and non recoverable. Okay, thank you guys for responding. Let me wait for a few more seconds. Okay, let's move to the correct answer. The correct answer is true because there can be an elastic regime which can be reversed or recovered, but once the drying creep or the basic creep happened, it is not recoverable, or even the shrinkage, it is not recoverable, it is permanent. So the statement is true. Okay, moving on to the next question. Creep during sealed conditions of concrete is greater than the creep during drying conditions. It's again a true or false question. Creep during sealed conditions is greater than the creep during the drying conditions. Okay, I got both true and false as correct answers. Okay, fine. I'm good to see the large number of people who are responding. That's nice. Should I wait for a longer time? Okay, I'll wait for a minute. Just read the question again. Yeah. Okay, I think that's all. So let's move to the correct answer. Correct answer is B because creep, there are two components. One is a basic creep and drying creep. Creep is basically the deformation due to sustained loading. But along with that, if there is drying, then what happens is the creep can increase. So when you seal the concrete, there is no drying happening there. And when you allow the drying conditions to happen without any problem, then the creep will be more. So here the statement states that in a sealed condition, creep is more, not in a drying condition. But I object and I say that this statement is false because there will be drying creep involved in the drying condition that can add to the normal creep, which is already there in the sealed condition. So, because of the additional drying occurring, creep during drying conditions is more. So, the correct answer is false. That is B. I hope you guys stay corrected. Okay, moving on to the next question. Now, as the temperature increases, the viscosity of asphalt increases, decreases, or does not change. Temperature does not have any influence on asphalt viscosity. Okay, yeah, I'm getting mixed answers here as well. So the question is when the asphalt, when the asphalt temperature increases, what happens to the viscosity? I can see multiple answers. Okay, should I wait for some more time? Okay, I'll wait a few more seconds, maybe. Okay, so the correct answer is B because the particles generally, when you heat something, the bonds between the particles break and they'll be more flowable. So, viscosity is the hindrance to flow. So, when a temperature is increased, generally it will be easier to work with the asphalt, or because of the viscosity reduction, it will be easier to work with the asphalt. I hope you get it. When you increase the temperature, what happens is that the molecular bonds between the materials tend to break because, yeah, that's then the viscosity tend to decrease, and it is more easier to work with a less viscous material than a highly viscous material. So viscosity, it is a hindrance, it is not a measure of easiness to flow. I mean, it is a measure of flow, but it is a hindrance. So temperature increases, viscosity decreases. They are opposite to each other. Okay, moving on to the next question. The internal rearrangement of the structure causes basic creep or drying creep. Yes. So the question is, the internal rearrangement of the structure causes basic creep or drying creep. Okay. Yeah, I have received a few answers. Okay. So let's move to the correct answer. Okay. Okay, I think answers are coming. I'll wait for a little bit more seconds, some more time, and then I'll move to the answer slide. So I have already told that there are two components. One is basic creep and drying creep. The internal rearrangement of the structure causes basic creep or drying creep. Okay, so moving on to the correct answer, it is basic creep. So drying creep is caused because of the movement of water, and basic creep is caused by the internal arrangement of the structure. Okay, moving on to the next part. Yes, the particle packing based approach of mixed design results in reduced creep or increased creep. So I hope you remember the particle packing approach in the mixed design. So following that particle packing can reduce creep or increase creep. Yeah, here also I'm getting mixed answers. Nice. I'll wait for a few more seconds. Okay, so Shrish, can you unmute and speak? Why did you choose option A?
I mean, particle packing based approach, we maximize the aggregate content such that there are minimum number of voids,
Mm-hmm.
which is further occupied by the cement paste.
Mm-hmm.
So we have already reduced the amount of voids that contain the water.
Mm-hmm. Okay.
Uh,
Makes sense. Thank you. Thank you, Shrish. So that was a correct answer. I mean, very precise because now in the particle packing based approach, we go for the mixed design such that we use only enough paste. So the paste content decreases and there will be more aggregates. And the component of the concrete which undergoes creep is not aggregate, it's the paste. So when you go for particle packing approach, there will be more aggregates and less cement or the less paste. So the creep will be reduced. So the correct answer is particle packing based approach results in reduced creep. Okay, moving into the next question. Creep at the external surface of a concrete element lesser than the creep at the internal surface. So there is some differential creep occurring. So is that a correct statement? Or if you consider an concrete element, does the creep occur uniformly at all the locations? Or is it the vice versa? Creep at the internal surface is lesser than the creep at the external surface. Okay. Thank you for your response, fast response. Okay, so I guess that's all. Let's move to the correct answer. Correct answer is B because the external surface is more exposed to the temperature fluctuations and humidity. So, an external surface experiences drying creep also. As a result of which, the external surfaces tend to creep more than the internal surface. So, the correct answer is false. Okay, moving on to the next question. Yeah, so for this, I'll give a little bit more time. So here is a question, different from what we have done till now. So suppose there is 15 kg of water kept in a rectangular box of length 1 meter and width 2 meter, and it evaporated within 5 hours. It totally evaporated within 5 hours. Choose the true statement from below and justify. So maybe justification need not put it in the chat box. You can just choose which is the correct statement. Evaporation rate is suitable to reduce plastic shrinkage. And option B states evaporation rate is not suitable enough to reduce plastic shrinkage. Okay, Gaurav Sharma has opted B, which means that the rate is not suitable enough to reduce the plastic shrinkage. Okay, getting more with B. Okay, so it's 15 kilograms of water in a box of length 1 meter, width 2 meter, and evaporated within 5 hours. Okay, I think there are more who can respond to this question. Let me wait for some more time. Okay, so I guess that's enough time for this question. I don't know why less number of response to this one. Okay, Naveed, can you explain why did you choose B? Naveed, can you hear me? Okay. What about Hemant? Are you in the meeting? You can even put it in the chat box if you cannot unmute. Hello. Mm, who's trying to speak? Okay, Gaurav, you replied fast for the first, yeah. Who's this, Gaurav or Hemant? I can't see that.
Gaurav from this side.
Yes, Gaurav. Yes, so,
The explanation for this is that the rate of evaporation for a suitable thing is that 1 kg per meter square.
yeah,
So
per
yeah,
hour.
this is the reason that's
Okay, so here, how much are you getting? Yeah.
3 kg,
How much?
3 kg in 5 hours, no? If we calculate it.
No, I guess it's 1.5.
Yeah, of course, sorry.
Yeah,
1.5. 15 is the area divided by the surface area and the
per hour.
number of hours.
Yeah. So here
Yeah,
the
1.5.
yeah, thank you, Gaurav. So here the evaporation rate is 1.5 kilogram per meter square per hour. So how much kg is being evaporated per area per hour? So in 5 hours, 15 kg evaporated from a rectangular box of area 2 meter square. So 15 by 2, the whole divided by 5 will be um, 15 by 2 into 5.
1.5.
Yeah, 15 by 2 into 5. It will be 1.5. So it is greater than 1 kilogram per meter square per hour. 1.5 is greater than 1. So the evaporation rate is not suitable to reduce a plastic shrinkage. So it has to be lesser than 1 kilogram per meter square per hour for it to be suitable for reducing plastic shrinkage. So the correct answer is B. Okay, moving on to the next question. When concrete is subjected to alternate wetting and drying cycles, the shrinkage increases with each drying cycle. So, this is again a true or false question. When concrete is subjected to alternate wetting and drying cycles, the shrinkage increases with each drying cycle. Okay, I'll wait for a few more seconds maybe. Okay, yeah, let me wait for a few seconds more because, yeah, answers are coming up. Ria, again, there is no option D. I hope it is you told B. Yeah, false. Okay, so moving on to the correct answer. Option B, because shrinkage it's high for the first drying phase, then as the drying and wetting alternate cycles prolongs, the shrinkage amount, the magnitude of shrinkage decreases, and it somewhat becomes stays a constant. So the shrinkage increases with each drying cycle is a false statement. Actually, the shrinkage decreases with each drying alternate wetting drying cycles. Okay, so let's move to the next one. In the restrained steel ring test for concrete for shrinkage, it is considered that the drying shrinkage strain of the concrete is greater than the strain experienced by the steel ring, and the drying shrinkage strain on the concrete is lesser than the strain experienced by the steel ring. The drying shrinkage strain on the concrete is equal to the strain experienced by the steel ring. Okay, I'll wait for some more time. Okay, we move to the correct answer. Correct answer is A. So if you see the screenshot from the slides, so the drying shrinkage strain in the concrete ring is balanced by the elastic and tensile creep strains in the concrete and in combination with the elastic contraction strain in the steel. So there is a shrinkage of the concrete that is a sum of strain experienced by the steel and elastic and tensile creep experienced by the concrete. So obviously these much things has to get added to get the drying shrinkage strain of concrete. So the drying shrinkage strain is more than the strain experienced by the steel ring because these two components are extra. Okay, moving on to the next question. Yeah, this is the last question. So there are two bridges, A and B. Just imagine. Let's assume that both the bridges have same specifications and load exerted. Everything is the same except the location. A is located at Rajasthan, B is at Chennai. With this given information, which of the bridge is likely to creep more in 20 years? So the question is about creep and magnitude of creep. Everything considering A and B are the same. The mix design, everything is same. Even the load coming is same. Rate of loading, everything is same. Only difference is that A is located in Rajasthan and B is a Chennai. So which of the bridge is likely to creep more in 20 years? Age of the bridge is also same. Only difference is location. Okay, I'll wait for a few more seconds, maybe. Yeah. Okay, read the question again if you have any doubt. So, which of the bridge is likely to creep more in 20 years? Okay, I guess those who can answer have answered by this time. Okay, moving on to the correct answer. Correct answer is A. So, the main reason is that at Rajasthan, compared to Chennai, temperature is high and relative humidity, especially, is very low because Chennai is a coastal area where the relative humidity is very high, and creep is affected by both temperature and relative humidity. An increase in temperature can cause more creep. A decrease in relative humidity can also induce creep. So, both these conditions are favorable for bridge A to creep more. So, that is why the difference in the creep between A and B, even though the material, age, loading rate, everything is the same. Okay, so here the factors playing are temperature and relative humidity. Okay, so that's all. Yes, let me stop presenting. Yes. So, thank you for being a good